Okay, in today's video, we are going to be multiplying with exponents. This is part of your laws of exponents. To start off, we just want a little reminder identifying the base, the coefficient, and the exponent. So here we have a term, 4x to the 7th power. The base, as we remember, is always what is it? The exponent is attached to. It's in this case, it would be x. Okay? X is our base. Our coefficient is 4 because we are multiplying x to the 7th power 4 times. So that is a 4. And then we have our exponent, which is the little number up in the upper right-hand corner of your base, and that is 7. So this x value is being multiplied by itself 7 times, and then after that, we are multiplying that value by 4 times. Okay. So what does that mean? Here we want to expand the following. X to the 3rd power times x to the 4th power. Remember, like a rubber band, expanding means to stretch, to make bigger. So x to the 3rd power means x times x times x. Now, x to the 4th power means x times x times x times x. So how many x's do we have here? We have 3, and then we have 4. So all together we have 7 x's. So that's where we get x to the 7th power. Now, how can I go from problem to answer a little quicker? If you look at it, we have a 3 and we have a 4. So if we just added those two exponents together, we get 7. So we can go straight from problem to answer just by adding our exponents. So that brings us to our product rule. Whenever we have bases that are the same, and that's very important. Notice here they're both x's. So we had 7 x's, not 3 x's and 4 y's or anything like that. The bases must be the same. As long as we have bases the same and we're multiplying, we can add the exponents. So we have our product rule is x to the a power times x to the b power would be x to the a plus b. If exponents are present, separate coefficients from the base. Coefficients follow the multiplication. So there are going to be times where you're going to have coefficients in problems. Coefficients will always follow our multiplication symbol. They will never be added. They will be multiplied. So here's our model problem. We have number 1 is 11 to the 4th power times 11 to the 3rd power. Now notice here, our bases are not variables in this case. They are numbers, and that's okay. As long as the bases are the same, we keep the base and we add the exponents. So 4 plus 3, which is 7. So we have 11 to the 7th power. Number 2, 2n to the 5th power times 3n to the negative 2nd power. It's okay with negatives. First, work out the problem. Then if you end up with a negative, then you can get rid of that negative at the end. That's always the last thing that you do. So here we have coefficients and bases. So we're going to separate them because remember, coefficients follow the multiplication and the exponents will be added. So here we have 2 times 3, which is 6. N to the 5 plus negative 2 is n to the 3rd power. So we have 6n to the 3rd power as our final answer. Now pause this video and take a shot at the check for understanding and come back and check your answers. Okay, so we have 5 squared times 5 to the 8th power. Bases are the same, so we have 5 to the 2 plus 8, which is 5 to the 10th. Now you can skip this part here if necessary and go straight to the answer, but I just wanted to show you what we were actually doing. Now, number 2, we have 3 terms, 4y to the 5th times 7y to the 3rd times y to the 6th. Bases are the same because those are what the exponents are attached to. The coefficients will be multiplied. 4 times 7. Now here we have a 1. Don't forget that one, even though whatever 1 is multiplied by it is itself. But for our y's, we have 5 plus 3 plus 6. So 4 times 7 times 1 is 28. Y to the 5 plus 3 plus 6, which is 14. And this is how we multiply with exponents, always remembering that coefficients get multiplied, exponents get added.